Hello, everyone. I am doing something a little bit different this time around. And instead of scheduling it live on LinkedIn, I'm actually recording this a little bit after the fact. I'm going to upload it to both LinkedIn and YouTube for you to consume. Part of it is just to experiment, try different formats, see how it goes. But also, I didn't want to take away from the fact that I'll be doing basically a debate with Saf in about 2 weeks and basically we're going to be talking about two topics. We're going to be debating when to use CTEs versus subqueries, and generally all things CTE related, as well as structuring data engineering teams. Should they be embedded? Should you have dedicated data engineering teams? So it'll be a good sort of lesson, or I would say like a good discussion, friendly debate. The other thing is neither of us like sort of this very abstract language, and we're going to try to go through some actual examples to show the specific, I would say like more concrete points of like using a real world example to show the benefits of one versus the other, and hopefully we'll try to like, I don't know, trick each other or stump each other with the way we're approaching things. And for this session in particular, I didn't get a lot of questions, and instead I figured I'd sort of just share something I've been pretty excited about and hanging around on, which is DuckDB. And I basically downloaded a few dummy examples here, and I'll demonstrate them, and I'll sort of like kind of walk through everything I've been messing around with. So let me quickly share my screen. So cool. So within here, and let me actually demonstrate some of the files. So in this case, there is two dummy files here, movies.json and evs.csv. So if you look at movies.json, lo and behold, it's just an array with a set of movies from the 1990s, and then in the EVs, it's a CSV file that has electrical vehicle data from the state of Washington. And once I load it in, we'll get a feel for it. But before I begin, I wanted to share basically like a bit about what DuckDB is. So for those unfamiliar, there's this shift. High level, there's two different types of databases: OLAP versus OLTP. So the OLAP is for analytical queries. So think Redshift, Snowflake, really anything that has these like big data applications. And there, the queries are designed. The typical query is really looking at like very large sets of data, and you're doing aggregate calculation of statistics, statistical tests, counts, sums. Versus OLTP is transactions, and that's typically when MySQL, Postgres are the biggest ones, and that's when you're trying to actually run, like any business where you need to operate like one row at a time in this table. You want to, let's say, pull some user information, you want to update an order, you want to create a new order or a new record. Like those are more transactional, and OLAP is more for like the analytical use cases. And so for the OLTP world, transactional, there's an open source database called SQLite. And that's actually, I think if you look at the stats, that is the most popular database because it's used in almost every app that you have on your phone. And think of it as like an idea of embedding a database. Like it does not run on the dedicated server. Instead, it's running locally on in your device, in your application. But it gives you the ability to run SQL. So DuckDB is the same idea. It's on duckdb.org, and I could sort of share a link to it in a sec. But within there, you're really just putting together the same sort of capabilities that you get of embedding like SQLite for transactions, but instead you're using it to embed like very much like a database designed for these analytics queries, but it's running once again on like a single node. So that's what I have here. So if I open up DataGrep, so this is the IDE I use that I'm a big fan of. So, and I mentioned initially we have the data loaded here, and I'm connected like within here to like basically like a single file, but it can also run in memory. So I do a select one, and like another really cool benefit here is you do select star from read JSON auto, movies.json order by year, right? So, or let's say without even that, you could have something like this, right? In this case, I'm saying, like it just very much like just read that file, and the other thing it automatically did was take each of the keys and create them as columns, right? So that's, in my mind, like really cool, just being able to like see something like this, because I didn't create any table at all. It's operating straight up on files, and if you look at how big this file is, it's about, like 25 megabytes. So pretty small. Like this does scale like pretty locally, right, to based really on the function of the memory on your computer. But it really could go up to, like gigabytes, like tens of gigabytes, like if you have the RAM on your computer to deal with it. EVs, like we'll take a look at it later, but just to give you a demonstration of what it looks like. Yeah, I mentioned like CSV file. Let's see how many rows it has. And it has about, 187,000 rows, right, a little under. So within here, we have these two files that we're messing around with, and I'm just showing off, how it works, right? So one, very simple, you can just run the query. And within here, you could really just do whatever you want, right? You can do year, count one, group by, right, group by one, group by year. Some other things it has that's pretty nice is you can do group by all, right? So suddenly that lets you, basically, if I keep expanding this, right? If I keep expanding the, sort of like the select statement to group by different dimensions. Let's say I want to do year, and here, maybe thumbnails. Let's say, I don't know, genres. I don't know if this will work, but let's try it. Oh, it will, right? So you could do like group by genres, and I didn't have to add it here, right? Instead, it just automatically worked because I just did the single group by there. And group by all, you could do like order by count, or order by 3 in this case, right? Lo and behold, right? So it's like pretty interesting, right? Being able to like just very powerful, being able to like query the data like this. The other thing, obviously, like you could do is like my typical workflow when I'm working with this is I could do like create table, movies as, and then you just copy this query over. And then I have select star from movies. And then very much like in memory, like exists here. And you could also save it persistent disk. So if we go back here, you'll see that this DuckDB file is really basically what I just created. It's like a single database. The other useful thing that I've been messing around with here is you could, very much like standard SQL, right? You could do alter movies, add column, add like first word of title. Oop, alter table, whoops. There we go, right? So if I do select star for movies, right, and sure enough, there's gonna be a new column here, first word of title. So, and then it has like, I would say like the standard operations that I'm gonna sort of poke around down here. I prepared a little bit, but you could do, select, like string split title, and let's say split by space from movies. Right, so what did it do? It split it into, by space. So if we want to get the first one, it's not 0 because it's SQL, so it's 1. And sure enough, right, you can do, it's after boarding Buffalo. So now we do something very simple, right? We could go in here, we could do update movies, set first word of title, equal, right, and then we go select star for movies, and first word of title. And once again, like within here, we could also start doing more of this fun sort of group by calculations, right? Like what is the what is the most popular first word? Oops, movies. Is he doing it live? Interesting, right? Like, is it anything unsurprising? Not really, but it's kind of cool, right? That we're just able to operate this way using like a local data set. The other thing I was gonna show off, just thought of actually, is so we have this table. Let's create a new one here called, and I'm doing this live, so we'll see if it works. But so within here we have genre, but you can see how there's arrays, right? And I don't know if they're always sorted, like it seems they might be, but let's not rely on it. But let's say we want to look at the most popular genre, right, of movie, like how would we do something like that, given that it's an array? So luckily for us, there's this function called unnest. So if we do unlist genres for movies, I gave it too many ends. right? And what did it actually do? So let's demonstrate exactly what it did here. Let me actually make it a genre. So what did it do here? If we see the genre, so this is the row, it basically splits it into, it duplicates each row, but it gives, but it splits it basically extracts each value in this array of a genre and then sort of duplicates it to each row, right? So if we have something like this, short documentary silent, you could see that it repeats the same, everything is exactly the same in this set of rows, except that now there's a genre column that extracted like each of the values here. So if, without necessarily like having to clean everything, right, we could do something like from movies by whatever genre again. Oh yeah, it doesn't like that. Okay, so in this case, like I think it just doesn't like the fact that like we're sort of dynamically generating this and then trying to do a group by. So this is where CTs come in, or we could do a subquery, right? So we could do like where movie genre as, let's actually call it MG to make things a bit faster. Now we do select no genre count from MG group by genre. What did it not like? Oh, there we go. By genre, order by to descending. So our data set, drama is the highest movie. The most popular drama is the most popular genre. Comedy is the second most. Least popular is found footage. And we could do pretty interesting things here, right? It's like, hey, I wonder what these movies are, right? So we could do something like select star from. This is like a bit of a hack, but I would do something where genre text like, right? So that basically converts it to text. Just do a very quick pull, and you could at least get a feel for the type of movies here. These are those like fake, sort of those virtual or sort of fake documentary style movies. So I mean, that's one example of what we could do here. I want to show off the other data set, which is like a CSV file. So let's see if I load it anywhere, because that's down here, right? Okay. So one thing is, let me demonstrate, similar to how we use this function to read the JSON files, we could also do the same for a variety of other file formats. So without even doing this, right, let's see what the autocomplete says, right? There's read JSON, CSV file auto, you could read Parquet, you could read text files. Like in this case, I'm doing read CSV auto, and the file is called evs.csv. And it's gonna fail now, right? Because I tested it a tiny bit before, and it's saying, hey, in particular row, so, oh yeah, in line 25,482, it failed because it expects this number, right, to be big int, or this census tract. It wants it to be, yeah, the way it works, right, is that this auto, it'll sample some of the initial rows in order to try to infer the schema, like what are the types of the columns. And this is basically saying, hey, I thought this column would be big int, but I'm suddenly getting a string called inc. And the solution here is there's an argument here called like, I think sample size. And you can say, how many rows do you want to sample? It's a relatively small file. So in this case, I'll just say whatever, select star from read CSV, sample size -1. And sure enough, it was able to read everything. And within here, let's do some quick stats on it. How many rows does this thing have? Once again, like 100. Yeah, this confirms what we did in the workout calculation, right? So if we do workout-L, like we'll see this is actually, here, zoom in a little bit, one more because of the header, right? So this number -1 gives us this many rows. And the way, let's see what it looks like here. Right, sure enough, so let's do create table EVs as similar problem to what we were doing, similar approach to what we did before. And now we have EVs. And what we do now, once again, is the same exact thing, right? We could look at the, let's do a variety of years, right? Well, we could look at the most popular models. We could say, like, make model from EVs group by all, ooh, we forgot count. And this one will do us count order by right? So the Teslas are the most popular ones. We could do the same thing, right? We could get rid of model, and the query just runs just by changing like a very simple piece here. And I mean, this is all in Washington, so I think state's always going to be WA, but we could confirm, right? We could, once again, like either do a distinct, but like I like the, oh, actually, look, there's a few more. I guess maybe these are like Washington residents that have their cars registered in other states, like who knows? Like we could also, do a query here where state does that. Let's see what's going on here. I don't know. Doesn't really tell us much. And by the way, this column here to the right, this 2020 census tract, is what failed to read the file in the first place. So if we go in here, and let's get it to fail again, just to repeat the error message. See, it's saying this 2020 census tract could not convert. And it looks like these are all numerical, but they're probably like some sort, yeah, I guess tract. So like some numerical zones, districts. Think of it like a zip code, right? It's a number, but it represents some geographic area. So here, so we could do something like this. I'll select from EVs where, I don't know. This part of the problem here is because there's, in the CSV file, you have these columns that have spaces, you have to quote it. And what was it, ink? Still didn't like it. Here, let's set for, yeah, I don't know. I don't know why it didn't want to load it. Good to get to it a little bit. But yeah, so these are some of the things that we do here. I started showing, like within here, I started working on showing off some of the regex and like regular expression and like string split calculations. So in this case, right, I noticed that the state, not the state, but there was a vehicle location, right, which looks to be latitude, longitude. And I was trying to say, is there a way for me to extract sort of exactly what it is? So right now it's string, and that's why I started working on this. So the first piece, basically splits it by space. So if you see that, let me comment it out. The other thing to be aware of here is there's a support for trailing commas, right? Normally, if you, like this works fine, but in some dialects, just adding a comma here would fail. Like with DuckDB, like loads perfectly well. And let's see what's going on here. Yeah, so sure enough, like this splits it into an array, and there's 3 pieces, right? Point, comma, or point, then the first sort of value in with the first parentheses, and then the second. So within here, what I was trying to do, working your way outwards, is something like this, right? This part extracts basically like what's within the parentheses, and then the last part splits it again by space. So you get 2 arrays here. And what I was doing before was like, hey, you could take the first one, or you could take the second one, right, latitude, longitude. So we could do something like this, right? We could do alter table, EVs, create column, latitude, double, long double. Let's see if this works. Oh, does it need to be add column? Yeah, I guess it wants you to do one at a time. Okay. So now let's do this thing. Now let's update EVs. Set lat equal 1. And I usually There we go. Nice. So now what we can do, I don't know, like, I don't know if it makes sense to do an average, right? You can do like average. You know, just to get a feel for it, right? Like where all these things are. You could do some pretty interesting things, right? Because we have state in there now. So we could also do state. Group by all, right? So kind of fun, right? Just getting a feel for like the different geographies, like where the states are. I don't know, maybe like copy into Excel to visualize it. I mean, this is interesting, right? Like there's some states, I guess these look to be British Columbia, that don't have anything, which makes me think, right, just the value's not set. And we could confirm. We're gonna select star from EVs where state equal BC. Yeah, and sure enough, right within here, yeah, we don't have vehicle location. The other thing I realized we should have done here is do a count one, right, just to see how many cars are in each state. So I mean, basically using something like this, you could have some fun and, you know, explore like data sets very quickly. The other thing I was gonna show off, and this goes back to here, is the way DuckDB works. As I mentioned, I'm accessing it through, in this case, I was accessing it through basically like the data grip, my IDE, but you could just as easily access it through code. So I'm like a fan of Python, so if I have something called like run.py, you could import, and I already installed it sort of globally, so normally you would have to do it, but you could do, I mean, this auto-completes. So in this case, right, you can specify to run it purely in memory, or in my case, right, I know that I have this file called DuckDB. So here, and we could do, I need that. So here, let's just test this thing for now. Doing something. Oh, here we go. I think it's here. Maybe it doesn't like the full path, so let's try it. I wonder if it's because I didn't save it. Huh. I don't know, in any case, I guess it didn't like it, but here, we can work on the in-memory version. And we do sort of like the same thing here, right? We do, what was it? Right, we could do create table. Let's see if this works. Nice. So now what we can do, and I think, let's see, I think you could do this. Oh, this is fetching as a data frame. That's also pretty interesting, right? Because now if I could do this, you automatically get built into a lot of the numerical sort of analysis support. It's slow, right? Because it's actually reading these hundreds of, like about 200,000 rows, but now it's a data frame. So you could do all sorts of like data science, statistical work on here. The other thing you could do is, there's a few different, like, you can fetch it as rows, like standard rows. You can fetch it as arrow. Yeah, so sure enough, you could like pretty interesting things. And that's kind of it, kind of what I want to show off, because I've been having a lot of fun working with DuckDB, both to do like this very quick analysis, but also embedding it in some of the programs I'm writing. Just whenever it's like, you know, oftentimes you could do things through code, you know, with like hash maps and lookups and joins and populating. But lately I've been finding myself that it's a lot easier to just load things into these tables, do the transformation in SQL, do the joins in SQL, and then extract the data back as rows. And that's it. I hope you all found this useful, and stay tuned for next yeah, I guess in 2 weeks where I'll be debating SAF. Thank you, everyone.